Greetings and good afternoon, math students. I hope you're having a wonderful day. We are going to look right now at a problem that is like what you're going to see on your homework. And you're also going to see problems like this on your quiz later this week, probably on Thursday. And our instructions are, we've seen many problems like this so far this year, and they have given us some struggle. So we're being asked to use the Pythagorean theorem to find the distance between the 2 points. Now, we've given 2 points on a graph. We're given this little guy to coordinate point 2, and then we're also given the coordinate point 4, 5. So we can see down here we're given 2 and 4, 5. And one of the things that this curriculum is asking us to do is to first find the slope of a line that connects those 2 points. And then secondly, it wants us to use the Pythagorean theorem to find the distance between these 2 points. And they're not asking us to do this just at random. They're asking us to do these two things together in order to see a connection and in order to make sure that we see how slope and the distance formula, which we will be developing a little bit later on, how those two things are connected so that you have a true understanding of the process rather than just trying to memorize this rote formula. All right, so first of all, what I would like to have us do is to make sure that we connect those two lines so that we actually see that we've got a line with obviously a positive slope because it is moving upwards and towards the right, and that what we're being asked to do, let's find the slope of that particular line currently. So if I look at it just visually on the graph, I can see that I have a rise of 3 and I have a run over of 2, so 3/2 would be my slope. Okay, so down here I've actually kind of mapped that out with using the slope formula. And if we use, I chose to use the second point as x and y1 and the first point as x and y2 so that I wouldn't end up with any negative numbers. So if I take y2, which is 5, right here, minus y1, which is here, and then if I put that over x2 minus x1, 4 minus 2, then I end up with 3/2. And we can see that slope has developed through the slope formula, and we can also see it visually appear on the graph. Okay, so now that we have that determined, let's actually tackle the second part of the problem. And the second part of the problem asks us to use the Pythagorean theorem to find the distance between 2 points. Now that understanding is that we're using the natural grid lines of the coordinate plane in order to create a 90-degree angle with this line. Okay, so what we're going to do is we're going to take a line and we're going to start to create that triangle. We're going to make this guy right here. There's one line, and then we're going to create another line over here. Here is my second line. And I'm just going to take a moment. I want to color code those. I'm going to make this little guy, oops, let's see, how should we do that? We'll go like this. We're going to make this guy blue, just so that we can see kind of what's going on. And we're going to come over here, this guy, and we're going to make him green. There we go. Alrighty. So we can see the two lines. We can actually see that the rise in this case is blue and the run is green. Okay. Now what happens now that we've created this, basically we've created a right triangle with a 90-degree angle, and our 90-degree angle we have making the assumption that those grid lines are at 90-degree angles so that we know we have a true right angle, and we can use the Pythagorean theorem in order to find the hypotenuse. Our line now with a slope of 3/2 becomes the hypotenuse. So let's see what that looks like. We know that a squared plus b squared equals c squared. That is the Pythagorean theorem, and the proofs are out there. There are tons of them on YouTube that you could check out, but we know that to be fact. Okay, and we are going to start information over here. We know, we can see that the blue line is 1, 2, 3 units long. We've established that down here with the rise of 3. So let's actually label that little fella with a 3 to make sure we don't forget. Okay, now we're going to label the green line with a 2 to make sure that that is not forgotten as well, so that we can start plugging things in. Okay, and it does not matter which of the legs. The hypotenuse is the side diagonal from the 90-degree angle, but it does not matter which of the other legs you label as A or B. Just pick one. It does not matter. In this case, I have chosen to label the blue leg as leg A and the green leg as leg B. Okay, so all I have done here is I have taken the 3 from the leg here and substituted into the Pythagorean theorem, and then I took the 2 distance here and substituted for B in the Pythagorean theorem. And it is extremely important to remember the hypotenuse, the one diagonal, the 90-degree angle, the longest side of a right triangle is the hypotenuse. Very important to remember that. And it is the side C. Okay? So let's continue with the simplification process. We know that from this point, all we have to do is take 3 squared. Please don't take 3 times 2, as many students tend to do when they're rushing. If we take 3 squared, and we get 9. When we take 2 squared, we get 4. And we just continue simplifying this, and we end up at 13, because 9 plus 4 equals 13, equals c squared. Now from here, we have to make sure we're still maintaining the balance of the equation. So what we do to one side of the equation, we have to do to the other side of the equation. And c squared is not fully simplified. And the only way to get c alone without the exponent 2 is to take the square root of c squared. So if I were to take the square root of both of these, all right, add that square root there, add the square root there, I am still maintaining balance on the equation because I have done the same thing to both sides. But what that does, this is kind of an interesting little trick. It takes c squared and square roots it, and therefore the square root of c squared is c. All right, so we end up with c there, but the square root still stays on 13. 13 is not a perfect square, so we cannot, or at this point we are choosing not to break it down into an approximation. We are just leaving it as an exact number as the square root of 13. So we have used the Pythagorean theorem in order to find the distance between 2, 2 and 4, 5. So we now know that that distance is approximately the square root of 13. We could plug it in to get it in the calculator to figure out an approximate number of units, but at this point we really are not terribly concerned with that. We just know that about square root of 13 is the distance between 2, 2 and 4, 5.